Hello everyone, Reza here with another Unreal Engine tutorial. In this step-by-step tutorial, we're going to make use of two very powerful tools, the Niagara VFX system and the level sequencer inside Unreal Engine to create a simple dragonfire effect, and the result will be ready as a cinematic piece. As usual, this tutorial is packed with tips and tricks on Niagara as well as cinematics in Unreal. So without any further ado, let's get started. As usual, let's start by preparing the scene. This is the dragon that I use for this particular tutorial. It's created by Trunk CG. I put the link so you guys can check it out. It's an incredible rig. I've gone ahead and put a very simple animation in there. There are a lot of problems in there, so apologies. The idea is not to really work on the creature animation, it's just to have this object so we can move on with our tutorial. So what I did, I geometry cached it, and then I exported this as Alembic into Unreal Engine. The other character that I'm going to use is from Mixamo. So if you go to Mixamo and search for Doozy, you should be able to find the Doozy character. Now what I did, I brought it with an act, attached an animation, and exported as FBX. So once that's done, I actually brought the two characters in there, put together a scene, and again the scene is just a bunch of mega scan assets, nothing too specific, and I'm ready to go. Now before we start with our project, because I'm going to use extra nodes within Niagara, we need to enable certain plugins. So I'm going to go into Edit and Plugins, and in here I'm going to search for Niagara and make sure that Niagara Fluids is enabled. It brings the Niagara Toolkit, and make sure Niagara Sim Caching is also enabled, because that allows us to put Niagara inside level sequencer so we can start animating it. Once that's done, you probably need to restart the engine and you are ready to go. Also, you can see I have a few folders already created in here. One to keep my level, another one to keep my material, to keep my props. So I brought these two characters into props. I've got an empty folder for sequencer. I've got a folder to hold my textures for the dragon, and an empty VFX folder so I can create my Niagara system and network in there. So everything is very organized, ready to go. So let's go to the next chapter and actually start putting together the nodes and move on with our tutorial. Let's get started. First things first, I want to create a Niagara system. I would like to create an empty system because I would like to add Emitter myself. And hopefully you all have watched my hour-long video on all the do's and don'ts you need to be mindful of when it comes to Niagara system. So prerequisites is to kind of have a basic knowledge of Niagara system, so we won't go over basic modules and attributes again. I'm going to press finish, and I'm going to call that NS for Niagara system fire. I'm going to double click on it and dock it right next to my scene. All right, I'm ready to go. You can see there is no emitter here. So right now everything is inactive. I need to add an emitter. Hopefully you already know, you can right click, add an emitter, or my preferred way is just to press E. Now once that's done, you go to parent emitter, and you can see now we checked those plugins and activated those plugins. Now we have access to a long list of presets ready to go emitters, so we don't need to build everything from scratch. Having said that, we are going to heavily customize these effects to be able to get the desired look. So I'm going to go with the Grid 3D Gas Master emitter, and if I double click on it, you can see I have the emitter working for me. So it's basically a sphere, and that emits smoke and density, to put it in a a better technical term, and it's quite buoyant. All right, first glance, if I look closely here at the emitter itself, you can see emitter update is empty, particle update is empty, so there is no modules in there. But then we have a bunch of presets, and those presets are going to help us to see the result right here. Now you can see that everything is locked because it's actually taking order from its parents, which is part of the template that we loaded. Now, if you ever want to tweak these manually and have access to them, it's actually quite easy. You just right click and you go remove parent emitter, and all of a sudden all of these attributes will get unlocked, and you can actually go ahead and tweak them. But for now, we really don't want that. We just want to start from scratch and shape the emitter. Now, what differs this from similar software packages, let's say like Maya, is you really can't turn this emitter inside Unreal Engine. So if I want to bring this emitter here and start rotating at 90 degrees so it points towards the right direction, we want the dragon to emit fire on this poor guy. Well, that's not going to work because it looks at the attributes. If I go to emitter summary, it looks at the velocity, it looks at gravity, and tries to figure out where the smoke is going to move. So just rotating it is not going to do the trick. We actually need to push the smoke on the X or Y axis in this case, to be able to get the desired look. But before I get into the technicality side of things, let's have a look at this emitter right here and see what we have to begin with. If I go to emitter summary, I have access to all the necessary tabs to get things going. First things first, simulation defines what you are simulating. Are you simulating smoke or density, or you would like to simulate fire, which is temperature? And those are here. So that's the first decision you need to make. Also, at the same time, you need to think about your boundary, this red box here, which you can enable and disable. Right? So I need to come up with a number that works for my scene, and also it helps the smoke to be pushed in specific axis if need be. So right now it just moves up, and this boundary box is more of a vertical boundary box. I want this to be more of a horizontal bounding box. So first thing I need to do is to change this world size of this bounding box to be able to get things going. I am going to put some random numbers in there, and I'm going to definitely tweak that because I really wouldn't know what number works for me. So let's sort of stretch that in y-axis, because I know my y-axis would be the longest one. The fire should be emitted from the left hand side to the right hand side, so this one gets the highest number. And for the height, I should say, or z-axis, I'm going to put something like 250, but I'm pretty sure I'm going to change that. All right, so far so good. So we have the boundary box. Let's actually move the emitter to the left hand side as much as we can, and that can be done by changing the local pivot. So I really don't want to move it in x-axis. So if I come here, I really want this to be at the center of my container. So x we don't want to move. I definitely want to move it in y-axis to push that back a little. Let's see if that is enough. Maybe 3.8 or maybe 3.5 works for me. I'm gonna try 4, maybe 4.3. Yeah, that's as far as I can go without actually getting into the boundaries. And you really don't want to do that because this emitter cannot live outside the boundary. And if there's any cutoff, you actually will see a seam. So to be safe, I'm just going to go with value 0.42. Now for the other one, Z, let's try to bring this down just a tad. Yep, that should work for me. So I positioned the emitter in the right place. Now let's think about how are we going to push this density along y-axis. There are a few ways of doing that. We have some really good forces available to us in the Forces tab to be able to get this done. But before I get into that, I'm going to introduce these tabs really quickly because we are going to go back and forth, and knowing what tab does what is actually quite important. So we already talked about simulation, density, temperature, and how fast density rises, buoyancy, how fast it vanishes or dissipates, dissipation rate, and we have dissipation rate for density, dissipation rate for temperature, ready to go, buoyancy for temperature, buoyancy for density. We have in source anything to do with the emitter. So we have the position of the emitter, local emit position, which is going to be ticked for us because we're working on a sort of local axis coordination. Emission radius is how much you would like to emit from this emitter, and that's a very, very important attribute. Disabling it will disable your emitter. If I put something like 20, you can see we are lowered the emission now, and 75 is going to help us to achieve the result. Now, something really strange is happening here. Maybe you haven't noticed it, but we have the reset button and we have another reset button. Now, this reset button is the parent emitter reset button, and this reset button is resetting the value to what you loaded to begin with. So if I click on this to 50, we still have the green one because we still differ from what the parent emitter asked us to do. So these locks become quite important, and if I click on that, then we're setting everything to what the parent was dictating. Now definitely we can change this, there's nothing wrong with that, but just be mindful of these two and what they do. So in the forces scenario, we can add force field, we can add turbulence, we can bring in some vorticity, which we are going to do. Collision deals with collision, and in here we have boundaries and start playing around with z-axis. For example, in here I'm going to go and open up positive z. You can all of a sudden everything hits the boundary and sort of deflects as opposed to just moving up and die. So that's the option that you have available. Render deals with anything shading wise, both for your density and for your temperature. Obviously for temperature, we're dealing with the standard black body, which controls the look of the fire that can be changed. And in render density, we deal with, all right, how much of a gain or opacity you're dealing with for the overall density, for your albedo. You can give it a range, so on and so forth, as well as smoke color. And then we have some less important for this particular tutorial tabs where you can override the quality, you can debug, and at the same time you can see all of these attributes at the same time. All right, let's deal with the direction of our smoke, and then we can move on to the next chapter and put final touches into the Niagara system. One thing you should be mindful of is never rely on this display 110%. Sometimes you bring this smoke into your scene and you see a slightly different result. So it would be a good idea to drag and drop your Niagara system early on and always sanity check when you think the result works for you. Another thing is definitely save as often as you can. Well, I'm saying this, I might as well save to be able to move on, because one thing I noticed is some of these nodes are still work in progress and they can crash on you at any point of time. Who knows, maybe it happens to me for this particular tutorial as well. All right, the direction of the smoke. the easiest way to get that going is by using the most powerful force inside the simulation tab. There are again many ways, such as velocity, to be able to push the smoke. My preferred method would be definitely gravity. So right now gravity forces the smoke to go up, and this is a standard gravity that you see in similar software packages. What I can do is to change that. So I am going to change that to probably 100, so it goes a little bit down, but at the same time I need to push it really hard in Y. So I am going to start with a crazy number, something like 10,000. And of course 10,000 is pushing it to positive. I need to go to negative, so negative 10,000 if I can type. And you can see all of a sudden we have this vigorous push in the negative Y. And again, it's out of place. You know, the buoyancy is not there. It's just too thick, too much emission at the same time, and they're hitting the boundaries. One way is to extend the boundary, but do we need to extend the boundary is something that we are going to check in the next chapter. So I am going to save this, and in the next chapter we're going to bring this in to our scene, and we are going to tweak our emitter to get a desired look. All right, let's put that into our scene. We're definitely going to get some really funky result, but that's totally fine. We're just really at the beginning of the whole thing. So yeah, you can see our poor doozy is getting completely destroyed and disappear. It's more like an exhaust pipe or some sort of a industrial scenario where you see super thick polluted smoke coming out of some industrial buildings. Nothing like a dragon fire, and that is expected. All right, at least we know what we're working with, and now it allows us to go back and forth and have a look at the result. Every time you make a change here and save, you can go and see an instant feedback. In the meantime, doozy, stay tight and just enjoy the smoke. All right, first things first, we just don't want to use density. We would like to use temperature as well, and temperature brings the fire vibe into our calculation. So let's enable temperature, and as soon as I do that, it compiles, and you can see we see elements of fire in there, but the smoke is too much to a point where we barely see fire. So let's go all the way, start from the top, and see what changes we can make. Resolution max, it changes the density of the cells in our longest axis, so it enhances our quality. It brings more detail into our fluid system, and while it can be very tricky for some mid-range computers to handle it, let's just be gentle with it. I'm just going to increase it by 100, and you can see we definitely get more detail. You can go up to 400, 450, but I noticed after 500 cells, everything becomes very unstable and even hard to process. So go easy on this. Never put a crazy number like 1000 in there. Otherwise, more or less, you're at risk of crashing, not to mention the scene is going to slow down significantly. Now, this pressure solve is very, very useful. It calculates the number of solves per emission and its accuracy versus speed. So you get better collisions, you get more accurate result. At the same time, your scene may slow down. Now I'm going to take the gamble and bring this up to 12 to enhance the collision side of things. But now I'm a little bit at risk of Unreal Engine shutting down on me, so I'm going to keep an eye on this. If necessary, you can reduce down to 10. I noticed 10 would be a sweet spot. 12 is a bit of a stretch, but we'll see how we go. I'm going to constantly save. Then we have density buoyancy, and this is something that we definitely need to address. I feel like it's very buoyant and it can go forever. I can even double the y-axis of my boundary, but it's still going to reach that area. So I may actually tone this down quite a fair bit. For now, I'm just going to start with minus 0.4, but you never know. I may actually change it down further. Maybe 0.3 will be a good number. I am going to play around with the gain, so I'm not really too worried about these guys fading at the moment. So that should do the trick. Now with temperature is the hero of the effect, and this density eventually needs to cater for the temperature. So I feel like having this set to 0.5 is just very, very low. I'm going to increase the temperature to a very high value, and you can see it's really pushing the density to the edges, which might be the result that you want, but definitely at this point it's really not working for me. I will pay attention to that, and I will make sure that whatever I do works well. In the meantime, I'm just going to snap back into here just to observe and see what type of look I'm getting. All right, now this compensate for actor motion is very, very useful. I won't be using it, but in case if you wish to move this up and down like so, you can see the fire is not reacting. It's very rigid. It's not really reacting to the movement. As soon as you turn this on, and this is something that you definitely see in so many of these scenarios, now the fire is actually reacting to the movement of my boundary. Very useful, but it's computationally can be a little bit expensive, and you definitely need to compile it before you go. As you may have noticed that when I enable it, it says you have to compile. It compiles it and then it goes. It can be very expensive, so don't use it if you don't need to. Now I'm going to dissipation. So dissipation is quite important, how soon you want the smoke to dissipate. Don't confuse it with buoyancy. Buoyancy is the initial push, how fast or how quickly your fire creates and gets created basically. But buoyancy defines, but dissipation defines how quickly it fades out, how quickly it dies. And this is something that you kind of need to be careful about. You can go negative if you want. For this particular example, I'm just going to go with 0 and see how it reacts. And for dissipation rate, for temperature, I may set that also to 0 to see how it reacts. Okay, not too bad. We can certainly do better, but let's move on to other tabs because there's a very significant change I would like to make. I'm not sure if you have noticed, but this emitter is way too big for the dragon's mouth. And as soon as I change that, everything else will tone down. And this is a direct relationship between the emission rate, the buoyancy, and the size of our emitter. And you will see me going back and forth and changing some of these attributes to be able to adjust my effect. Now in here with our sphere source, which is the shape of the sphere, we would like the emitter to be active and enabled, and of course have all the necessary attributes ready to go. The non-uniform scale is what I'm targeting, and emit radius is also very, very important. Now with this non-uniform scale, I really don't know what would be the magic number. So let's start with 0.3, 0.3, and 0.3, and everything else will tone down as a result of that. And now you can see why having this attribute is very, very important. I'll go and quickly check how it looks in the scene. So yeah, not too bad. Would be a better option if I put everything in a timeline so I can check, but I feel like it's not too bad. It's going well. The dissipation also works kind of well, but I need to make a decision on what exactly I want to do with the density so the fire shows better. But you can see what I was talking about, a slight difference between the viewport here and the actual level. There's a slight difference in terms of the look. So anything that you change, you definitely need to go back and have a look. All right, for now, it's not too bad. It's working for me. I can go in there and specify how much density and how much temperature I would like to get. Now, density is way too much. You may have noticed that I'm almost getting just smoke, and the density value is set to 5, which I think it's a very, very high number. So I'm reducing the density, and even the temperature is still, I think, too high. So I may go and reduce that to something like 3. I'm going to save, and let's have a look. I'm getting a slightly better result, but I really would like this fire to actually reach the character. So what I'm going to do, and every time you want to elongate your flame, best friend is emit radius. I'm just going to go and put 100 in there, and it gives you an extra push, which actually looks quite nice. Also, I feel like the emitter is still a bit too big, so I'm going to reduce that to 0.25. And remember, every time you do that, it will have an impact on your emit radius, and it will have an impact on the level of density and temperature that you have in the scene. I'm going to save. I'm going to have a look, and yeah, the fire does reach at some point. Maybe I need to increase that to 120 and increase the temperature to something like 4, and even reducing the density to something like 1. Let's go back and have a look. Yeah, that definitely is better. I quite like that. Now, next tab is forces, and in here you have some really cool attributes to play around with and to deal with, and we are going to make use of it. Now, the first one that is super useful is vorticity. I'm going to probably increase that to 3, and that creates small vorticities into the scene, but also I would like to create some chaos. And your best friend for chaos is always turbulence. Now, turbulence is going to give you the main waves, the sinus waves, as well as the chaos that you bring with vorticity. So I can just increase that to a very high number just to test. And now you can see chaos is everywhere. I really like the result right now. So with that out of the way, you can see I'm gradually but surely moving forward and stepping into things that I like. Maybe 0.3 was a bit too much, so 0.25, the original value, I think kind of 2.5, I believe. The original value does work for me. And with this turbulence frequency, I feel like I can definitely push that really high to just bring more chaos into the scene. Now, with regards to some really important attributes in there, with regards to this turbulence gain, you can actually gain down your turbulence while you're setting it to a very high value. I found that it's actually quite useful. Slight touch on that is going to have that little bit of balance in there, which is good. Now, I really feel like I need to go into source and make some adjustments in there. So first one is temperature. For temperature, I feel like it's a bit too much, so maybe 3 should work for me. For emit radius, I feel like it's emitting now too many, or too much, rather. So reducing it down to 100 gives me a little bit of balance in there. Everything else more or less looks good, and we can always go back and tweak around with some of these attributes. I'm going to go into simulation to see what I can improve to get a better result. Maybe buoyancy of 0.04 for buoyancy for the density is a right move here. Now again, it's really hard to see exactly what's happening. I need to save and switch back into the scene, and you can see more or less the smoke is what it bothers the character. I really don't want to burn the character. I just want that to be the smoke. I guess we are in a position to add some final touches in the render, and the rest we can fine tune once we put things on the level sequencer. So I'm just going to quickly pay a visit to render to see how we can change things in this very important tab. It's a decision you need to make if you would like to go with the fire look, or if you would like to change that fire look to more of a sci-fi look, and or let's say, I don't know, a toxic poisonous green look, just to, you know, have fun with it and add variety. At this point I really don't have any brief, so I can just go nuts and change stuff. You know, no one's going to ask why. So just for the sake of demonstration, so you guys get to see how this works, let's actually go through that. I personally would preserve the fire look and more work more on the fire look, but for now it's an opportunity for me to explain more about this incredible system. So let's go ahead and change that fire look to something else. Now to change this black body, obviously none is not an option because you're completely going to kill everything. Black body is the default fire look. The other one is curved, that allows you to actually put a color chip and customize the look of your fire, or whatever you want to call this at this point, because we are going to change it. Of course, you can just toggle the snapping here, so I can just have snap enabled and it snaps. If you want more delicate movement, you can go with that. You can change that to curve this display here and really play around with your RGB values. But if you want something that it's kind of visually easier to read, definitely you can go with that. Now the way that you change this is by just double clicking on it, and now you have access to all the you know, all the colors that you want. For example, I can sort of change that to a toxic type of fire. I don't know why it's toxic, maybe the green. And you can even change the value to something like 1.5, so it actually emits light as well. So you're really crunching the value, or actually pushing it high up to be able to create some indirect illumination for your fire. And you can see now it actually does illuminate the scene, and Lumen does a fantastic job of showing that. Now with the smoke right here, I feel like I can tone down the opacity of the smoke because it's just way too thick, and now it's a lot transparent. You can even go and push that to something like 0.4, and I feel like this white doesn't really go well with the color of my fire, the new color that I came up with. So I'm just gonna change that to something that makes more sense, maybe slightly darker color. Yeah, that should really do the trick. I don't mind that. And of course, we can always go back and change stuff. You can bring other colors into the mix if you want to. It's always an option. And the beauty of that, it's at any point of time, you can go, and you can see I'm bringing some yellow into the scene now. You can totally see that. You can even go with that and change that to something like blue. Yeah, it's just spreading some blue now, which is good. Maybe this 1.5 is a bit too high. Maybe 1.25 is a better number. It was just way too bright. And if I check that, You can see it's coming together nicely. Now the smoke is not as thick. So you can see that the process is really the focus of this tutorial, and how gradually but surely I'm getting closer and closer and closer to the final result. Now I definitely reached the level where I need to see things in action. The character, the dragon character, gets closer during its main pose to the other character. So I really need to check if the fire is too close, if my emit radius value is too high, if the buoyancy is there. So let's go to the next chapter and put everything into our level sequencer. I've got a folder ready to go, so let's move on to the next chapter and take care of that. Now, first things first, I need a level sequencer. And again, I have a video or a tutorial, and the entire video talks about level sequencer and all the do's and don'ts you need to be mindful of. I put the link to that in the description below also, so you guys can access it. If you don't know anything about level sequencer, I highly suggest you to watch that first. You can pause the video, watch that, and then come back and continue, so we don't spend the time on all the basics because we've already covered that. But for this particular one, I am going to add a level sequencer. I'm going to go into my sequencer, and I am going to call that SEQ for sequencer underscore fire, just the simplest name possible. Now let's bring all of our characters and bring the Niagara system into level sequencer. That's going to be quite interesting, because with characters it might be straightforward, but the Niagara system, that can just throw some curveballs on you, and we need to see how we can plan that out. Now, first character is our dragon. So you have two ways of doing this: simple drag and drop, or select your object via the outliner, go to track, actor to sequence, and because you have selected this, that would come up as an option here for you. Now, on a good day, if you play by the rules, bring in the skeletal mesh and then your animation and bind them together as an FBX, the sequencer will detect the animation. So that's no problem, something that we are going to test with our doozy character in a second. But this one, I geometry cached it and I export it as Alembic. So the process is slightly different. And again, I did that intentionally simply because it's another excuse to talk about something new, something that we haven't talked about. What's going to happen if you geometry cache your animation? How are you going to bring it as an Alembic? So the process is actually fairly straightforward. I'm going to click on the track, and because I have geometry cache, when I imported my animation, I made sure that the geometry cache was selected. The sequencer can now access that geometry cache. As soon as I click on it, I have my animation ready to go. So that's good. I noticed that I need to relocate and change the position of my emitter. I will definitely do that simply to get a better read. If I can somehow access the scene, I keep clicking on different things. Okay, let's find our Niagara system. W to move and bring it to the scene. Now, while I'm at it, why don't I check the radius to make sure that the radius works for me? Yeah, that's actually not too bad. It certainly, it definitely works for me, at least at this point, but I can always go back and change that. I'm just going to ever so slightly move that in Z and Y just to position it better. That gives me a better read. And now it's a lot easier to see what's going on. It's a lot easier if the fire can actually reach the character, and you can see the incredible collision that happens because of the solver rate that we increased from 6 to 12. Now we're getting a really nice collision. First character done. Let's bring doozy. So let's see. Happy, that's the doozy character. Of course, I need to be in my very first frame, otherwise you start right in the middle. You can drag and drop it. You can go to track and bring the character this way. It really doesn't matter. Now, if I go and check, surprisingly, you see there is no animation, and you would be surprised why, because we already brought the skeletal mesh. We did the bind between the geometry and the animation. Why it's not really looking at it? Simply because the animation track is empty, and in here you have to go and address it. Every time you bring a skeletal mesh, this is something that you should be doing. Now I have two from Mixamo, and I noticed that this take one is broken. So if you are following this tutorial with the exact same character, you can go with this Maximo one, and that works. Well, I was talking about the playback head, not to be in the middle, but to be in here. And of course, I made the same mistake, but that's no problem. You can always go and just snap it back to frame one. And you can see Doozy is now very sort of cheerful. It couldn't really care less about what's going on, which is kind of funny by itself. I thought I would just bring a little bit of contrast into the scene. So if I just play, you can see it's just having fun, idle position, not doing anything specific. All right, so the animation is there for the dragon, and for Doozy, let's bring Niagara. The process is still very straightforward. So I'm going to select my Niagara. I'm going to make sure that I'm in my very first frame, go to track, actor to sequence, and add Niagara. Now that's the part that it gets a little bit confusing, because Niagara doesn't have any other sub layers like animation or transform. You have to add them manually. So thanks to the plugin that we enabled right at the beginning of our tutorial, if I press on this plus, I have now access to Niagara components. That gives me access to certain components, so I can just tweak few attributes. So I'm going to click on that, and it brings the Niagara component. But again, it just doesn't do anything, because you need to go one step forward. And that is, if I click in here, you have access to certain stuff, not everything, just certain options at your disposal. You can transform, you can play around with cast shadow, affect distance field, you can tweak the mobility, right? But one of them that is actually very useful is this Niagara system lifecycle track. If I bring this one here, that actually allows us to enable and disable the Niagara system at certain point in time, which is very, very useful. I feel like I need to extend my timeline because I no longer see what's going on. So if I go through this, you can see now we do not have any emission. And as soon as I hit this point, I have my Niagara system, and I want this to be cut off here, maybe. So that's easy. I'm just going to bring this one back, and you may feel like, all right, it's done. However, if I play, it just cuts off with no sort of follow through in the flame. It's as if we pressed delete on it. So very, very unnatural. Also, I noticed that it wouldn't harm if I translate that emitter ever so slightly, because it pushes back. So would be a good idea to go in there and drop in a transform, so we can be a little bit more accurate with things. Feel free to change the interpolation. At the moment it's set to cubic, which gives you tangents to overshoot, but at some point you probably don't want to have any ease in or ease out. In that case, you go linear. And of course, you can just switch to curve editor and tweak things further. For this particular animation, we don't want to spend too much time on the animation. That should work for us. But again, this is quite annoying, where the fire disappears really, really quickly. I probably don't want that. And I feel like I'm reaching a level where I can just add further tweaks to this particular flame and look of it even better. So let's go to the next chapter and make final touches to this flame, finalize it, quote unquote, and then deal with this cutoff effect that we get inside the level sequencer. All right, back to Niagara system. Now, I can spend honestly hours on this just to add final touches, bring in some particles, work on the shader some more, but I don't want to spend too much time on it. So let's just tweak a few attributes and then deal with more important stuff, which is animating Niagara inside our level sequence. So one thing that it can actually be improved is the unused portion of this container. You know, I didn't know that I would reduce the size of my emitter to something small. So now this, if I go to simulation, this 1200 is certainly a large value to deal with. Let's see if I set that to 1000, maybe 1100 is better. And in the meantime, I am going to save. Yeah, that's definitely a better option. Also, another thing that I can probably help with is the dissipation rate density. If I set that to a super, well, 0.5, you can see I don't get any density for the smoke, so that wasn't really an accurate value. Maybe 0.1. I just want to cut off a little bit of smoke early so it doesn't live forever. Yeah, that's definitely a much better option. I don't want the puff of smoke to sort of reach the end of the container. It was a bit of an overkill. Maybe 0.15 is a better value. Yep, I'm gonna go to source, and I really would like to add a little bit of velocity in there. And this is just a push that I will get for the fire, which is our temperature. So that is definitely a much better option here. And yep, it's actually not too bad. If anything, I really would like to increase the, it's very tempting to increase the max axis, which is our resolution of the fire, just to get more details into the scene. Now that definitely works, but every time you change max resolution, you need to little bit be careful about the level of dissipation, and you need to be careful about your emission rate. So it's always a trade-off. Now I think if I reduce that to 95, that should give me a good result. Yeah, I still would like this to reach the character, so I might as well stay at 100. All right, I'm in a good position to call it a day because, again, you may have noticed that I'm going back and forth, and I can honestly stay half a day on this just to be able to get the result that I want. But I think you guys got the gist. You guys know all the key attributes to target now. So let's go into here and let's talk about what we should do to be able to control certain attributes that we don't have in our Niagara component. What I really would like to do is to have a fade-off effect on this emission, to be able to control the emit radius. This is the one that we need to target, and somehow we need to find a way to bring this attribute into our Niagara component inside the level sequencer. And this scenario is something that you will run into one way or another when you want to keyframe an attribute, and that attribute is not keyframeable. Just to show you, if I go in here into Niagara, there is really no way of keyframing this in here. So we don't have any options to keyframe any of these properties inside the Niagara Fire. And even if I want to do that in here using the good old keyframe, I still can't. And despite the fact that I have the Niagara system on my level sequencer, there is no level sequencer icon popping up right next to the attribute, certain attribute, just like, you know, lights. When we bring in lights, we always get the camera sequencer icon when we can keyframe them directly from the properties detail panel. We don't have that option here either. So that's the part that many of my students get confused. They don't know where to move forward, and they just settle on just a simple fire vanishing, and they just called it a day. Now, there's a really easy way of keyframing any of these attributes, and that is by using something very useful, creating a user parameters. Now, using a user parameter happens inside your Niagara system, not Niagara Emitter. So let's talk about that. You can, if I zoom in, I'm going to hold down Control and zoom in. Now, there is a way to add your custom user parameter to be able to add to your Niagara system. Now, in Unreal Engine 4, there was a plus button here where you could add a custom user parameter. In Unreal Engine 5, it's actually down here, and this plus right here allows you to add a user parameter. Now, the user parameter that I'm looking for this particular example is float. And the reason I'm picking float is because I may go decimal values, and I need to bank on that okay, if I want 2.75, the float value is still going to cater that for me. I'm going to call that custom user param for parameter. And all of a sudden, I have a custom user parameter. Now, how to link that into my emitter is also quite simple. What I'm going to do, by the way, I'm going to select the user parameter and make it the same value as the attribute that I'm targeting. Again, the attribute that I'm targeting is, if I go to source, is emit radius, and it's right now set to 100. So I'm going to make that 100. So now there's no difference between this parameter and this parameter. They all do the same thing, and all you need to do is set to the emitter that instead of driving the value from this live feedback, drive that from your custom user parameter. So I'm going to make sure that show all is selected, and I'm just going to search for our custom user parameter. Now, all of a sudden, instead of running it from this live feedback, I'm running this from the parameter. And because those two values match, I technically should not see any changes whatsoever. You may say, Reza, what's the big deal? What just happened now? Well, we can bring this into our level sequencer. All of a sudden, we provided a situation where we can actually target a very specific node on level sequencer. That's fantastic. Let's go back. And if I now go to Niagara component, the plus, look what we have. Custom user parameter, and you can actually bring that into your track. So I'm just going to move to the very first frame and then go into Niagara, custom user parameter. And this is keyframeable, believe it or not. So what I'm going to do, I'm going to start by adding a default keyframe and then keep that for a good amount of time. Maybe it's fading now to a value of 80, and then it around here it dials off to something like 0, and of course for that I need to increase its life cycle. Now, instead of you watching me tweaking these keyframes, I'm just going to pause the video, and I'm going to readjust some of these keys, and we can sort of put final touches and finalize our tutorial. So I ended up actually, I noticed that I'm not getting the result that I want, the force that I want. So I ended up pushing the gravity a little bit and reducing the emitter to a slightly smaller value. So from 0.25 to 0.23. And I feel like it's now, it's a much better fit for the dragon. So if I look at it from this angle now and play rewind, you can see I'm getting a better result. Obviously, there is still tweaks need to be done, but you know, for 3 minutes, I think it kind of works okay. But you can see how easily I can now go back and forth and tweak some of these attributes to my advantage and get the result that I want in no time at all. So if I look at it from this angle as well, you can see it hits the character really well, and the fade out is gradual from one to another keyframe using this custom user parameter that we used. So that's all good. Let's drop in a light into the scene. So maybe a point light. And perhaps I'm going to go and kind of use the same color in here. Now it's time to bring it to the sequencer. So I'm just going to drop in the point light camera sequencer, and I comfortably have access to its intensity. You can see the intensity is right there. And all I need to do is to line up the intensity of my light to the fire, the emission of the fire. So I'm going to go in here. That's the fire starts emitting. And I'm going to click on the intensity. And it can go on all the way to here with intensity of 0.5. And of course, it dies after the fire fades away. So I'm going to set that to 0, the intensity, and it creates a keyframe for me. So that's going to work just fine. And of course, right before that, I'm going to set that to 0. So it only shines on the character when the fire emits. So let's rewind. Maybe slight delay. So let's have a look. Something like that. So you can see how much play you get from some of these incredible options that you have available inside the level sequencer. And the whole idea behind this tutorial was to show you the amount of flexibility that you get when it comes to level sequencer, and how you connect certain attributes and options from your Niagara system and you bring them directly into your level sequencer, just to be able to make them keyframeable and to be able to customize certain attributes over time. That should do the trick for today's tutorial. I really hope you found this video useful and use the techniques you've learned to your advantage. And until the next video, see you guys later.